Welcome to this session on Azure Storage, Backup, and Site Recovery. Every cloud journey eventually comes down to data, where it lives, how it is protected, how it is recovered when something goes wrong, and how it is secured against unauthorized access. In this session, we cover all of that ground. We will start with Azure Storage, which is truly the foundation of every service in the Azure ecosystem. Then we will look at Azure Backup for protecting your workloads and Azure Site Recovery for disaster recovery and cloud migration. From there, we go deeper into Azure SQL Database, covering how to set up high availability using geo-replication and failover groups, how to secure databases with advanced threat protection, auditing, dynamic data masking, and transparent data encryption, and how to monitor and automatically tune database performance. Finally, we close by stepping back to look at the broader Azure data and analytics platform and what options exist beyond SQL Server. Let us begin. Here is an overview of the 6 main areas we will cover. First, Azure Storage, the foundational service that stores virtually everything in Azure, from virtual machine disks to backup files to application data. Second, Azure Backup, Microsoft's managed backup service that protects virtual machines, SQL databases, on-premises servers, and file shares. Third, Azure Site Recovery, or ASR, the service used for disaster recovery and workload migration, enabling you to replicate on-premises machines to Azure and fail over in minutes. Fourth, Azure SQL High Availability and Failover, how to create geo-replicated database copies and configure failover groups for automated, application-transparent failover. Fifth, Azure SQL Security, covering the full security suite including threat detection, compliance auditing, masking sensitive data from non-privileged users, and automatic encryption at rest. And sixth, monitoring, automatic tuning, and backup, the tools that help you identify performance problems, automatically fix them, and ensure your databases are always recoverable. Let us start with the most fundamental of all these topics. Azure Storage is not just one service. It is a family of 4 distinct storage types, and together they form the backbone of virtually everything that runs in Azure. Every virtual machine disk, every database backup, every application log file, all of it ultimately lives in Azure Storage. Let's go through each type. The first is Blob Storage. The word Blob stands for Binary Large Object, and Blob Storage is designed for unstructured data. Things like images, videos, audio files, log files, and documents. It supports 3 types of blobs. Block blobs are ideal for text and binary data, such as files and documents. Page blobs are designed for random read and write operations and are what Azure uses internally to store virtual machine disk files. And append blobs are optimized for write operations that always add data to the end, making them ideal for logging. Blob Storage also has 3 access tiers: hot for frequently accessed data, cool for data that is accessed less often, and archive for data that is rarely accessed and can tolerate retrieval delays. The second type is Azure Files. This is a fully managed file share service in the cloud that uses the SMB protocol, the same protocol Windows uses for its network file shares. You can mount an Azure file share on Windows, Linux, or Mac OS as if it were a local drive. This makes Azure Files an excellent replacement for traditional on-premises file servers, and it supports Azure Active Directory authentication for access control. The third type is Queue Storage. Azure Queue Storage is a messaging service that stores large numbers of short messages. Applications use queues to communicate asynchronously. One part of an application writes a message to the queue, and another part processes it when ready. This decouples different components of an application, making the overall system more resilient. Each message can be up to 64 kilobytes in size, and a single queue can hold up to 500 terabytes of messages. The fourth type is Table Storage. This is a NoSQL key attribute store designed for massive amounts of structured, schema-less data. It does not use SQL or a relational data model. Instead, you store data as rows with a partition key and a row key, which enables very fast, direct lookups. Table storage is extremely cost-effective and is well suited for scenarios like storing web application session data, device telemetry, or user profile. Now let us talk about Azure Backup, Microsoft's cloud-native backup service. Azure Backup provides a simple, scalable, and secure way to protect your workloads without needing to deploy or manage any backup infrastructure. There are no backup servers to buy, no tape libraries to manage, and no off-site media to ship. All backup data goes directly to Azure, stored in geo-redundant storage. What can you actually back up with Azure Backup? You can back up Azure virtual machines, including both Windows and Linux VMs, with application-consistent snapshots. This means the backup captures the system in a clean state that can be restored without issues. You can back up Azure SQL databases, though as we will see later, SQL databases also have their own built-in automated backup that runs independently. You can protect on-premises Windows servers by installing the Microsoft Azure Recovery Services agent, which allows file and folder backups from servers in your own data center directly to Azure. You can back up Azure file shares in their entirety or at the individual file level. And you can back up SAP HANA databases running on Azure virtual machines, with certified integration that ensures backup and restore operations are consistent with SAP HANA's transaction model. The key benefits of Azure Backup include truly zero infrastructure requirements, geo-redundant storage that replicates your backup data to a secondary Azure region automatically, granular recovery options so you can restore a single file or an entire machine, long-term retention policies that can keep backups for months or years, and encryption that protects your data both in transit to Azure and at rest in Azure Storage. Azure Site Recovery, commonly abbreviated as ASR, takes data protection a step further. While Azure Backup protects against accidental deletion or data corruption, ASR protects against much larger failure scenarios, entire site outages, region failures, or major hardware disasters. ASR continuously replicates running workloads to Azure. If a disaster occurs and your on-premises site goes down, you can fail over to Azure in a matter of minutes. When the on-premises environment is restored, you fail back just as easily. ASR supports 4 primary replication scenarios. First, on-premises VMware virtual machines replicating to Azure. This is one of the most common enterprise scenarios. Organizations running VMware vSphere on-premises can replicate those VMs directly to Azure and fail over during outages. Second, on-premises Hyper-V virtual machines replicating to Azure. Microsoft's own hypervisor platform is fully supported, whether the VMs are managed by System Center Virtual Machine Manager or not. Third, physical servers replicating to Azure. Even bare metal servers running Windows or Linux can be replicated to Azure, where they become virtual machines during a failover. Fourth, Azure virtual machines replicating to another Azure region. This is the scenario where you replicate Azure VMs from one region, say East US, to another, like West Europe, for regional disaster recovery. For disaster recovery purposes, ASR offers continuous replication with a recovery point objective as low as 30 seconds for VMware workloads. Failover can be triggered with a single click. Recovery plans can orchestrate the startup sequence of multiple machines in the correct order. And critically, you can run non-disruptive disaster recovery drills, testing your failover without affecting production at all. For cloud migration, ASR is equally valuable. You use it to replicate on-premises workloads to Azure, test the migration without any downtime on production, and then perform the actual cutover at a planned time with minimal interruption. Now we shift to Azure SQL Database and the topic of high availability. Creating high availability for Azure SQL Database is dramatically simpler than doing the same on-premises, and it starts with a feature called geo-replication. Geo-replication allows you to create a continuously synchronized, readable copy of your Azure SQL database in a different Azure region. The copy is kept in sync in real time by replaying transactions from the primary database on the secondary. To set this up, you go to the geo-replication blade in the Azure portal, which shows a world map. On the map, your current data center is marked in blue, the Azure recommended replication destination. Usually the geographically closest available region is marked in purple, and all other available regions are marked in green. You simply click on any region on the map to begin. This opens the Create Secondary blade. Here you select or create a target SQL server in the chosen region. Confirm the database name, which will be the same as the primary, and optionally change the pricing tier. Note that the secondary database will be in read-only mode by default. After deployment, the map updates to show the connection between your primary and secondary databases. Deployment time depends on the size of the database, because Azure first creates an empty database in the secondary region and then copies all data from the primary. Now, there's an important limitation to understand about geo-replication on its own. The secondary replica is readable, meaning you can use it for reporting queries or as a read-scale endpoint. But in the event of a primary failure, the secondary does not automatically become the primary. You would need to manually promote it from read-only to read-write mode, and you would need to update all your application connection strings to point to the new primary. That is a significant manual intervention during what is likely already a stressful outage situation. To solve this, we need failover groups. Failover groups build on top of geo-replication and add the crucial layer of automation that turns a readable replica into a true high availability solution. The concept is straightforward. You define a group with a primary server and a secondary server. Azure creates a single, unified endpoint, a URL that looks like your failover group name .database.windows.net. Your application always connects to this endpoint, never directly to a specific server. When the primary server is healthy, all connections through the endpoint go to the primary, which handles both reads and writes as normal. If the primary server becomes unavailable for any reason, hardware failure, network issue, regional outage, Azure detects the failure and automatically promotes the secondary server to primary. All new connections through the failover group endpoint now go to what was the secondary. Applications that were connected get reconnected automatically without any manual intervention. When the original primary comes back online, it rejoins the group as the new secondary and begins synchronizing again. Eventually, Azure can automatically fail back to the original primary if you have configured it that way. Let us look at the configuration options in the failover group blade. You need to provide a primary server, the source SQL server. You provide a secondary server, the target SQL server in a different region, which should already have a geo-replicated database in place. You give the failover group a unique name, which becomes the connection endpoint. You configure the read-write failover policy. Automatic means Azure decides when a failover based on availability health. Manual means a human must trigger it. And you set the grace period in hours, which is how long Azure will wait before automatically triggering a failover when it detects that the primary is unresponsive. The result of all this is a database high availability solution that requires zero ongoing management. Failover and failback happen automatically, and your applications are completely unaware that the underlying database has changed locations. If you have ever managed SQL Server always on availability groups on premises and experienced the complexity of a manual failback procedure, you will immediately appreciate how much simpler this is. With high availability in place, the next critical area to address is security. Databases contain some of the most sensitive information in any organization: customer records, financial data, personal information, passwords, and more. Azure SQL Database offers a comprehensive, layered security model. There are 4 main security features we will cover in detail. The first is threat detection, which uses machine learning to analyze normal database behavior and generate alerts when something suspicious occurs. The second is auditing, which logs all database activity to a storage account or log analytics workspace, so you have a complete record of who did what and when. The third is dynamic data masking, which allows you to control what data different users actually see when they query the database, hiding sensitive columns from unauthorized users without changing the data itself. And the fourth is transparent data encryption, or TD, which encrypts all database files, backup files, and transaction logs at rest, protecting the physical data even if someone were to obtain the raw storage files. Let's look at each of these in turn. Advanced Threat Protection is Azure SQL's umbrella security feature. It contains 3 distinct subsections: each addressing a different aspect of database security. The first layer is data discovery and classification. This feature performs an automated scan of your database and identifies columns that may contain sensitive data, things like names, email addresses, phone numbers, credit card numbers, national identification numbers, and so on. It then provides recommendations on how to classify those columns, tagging them with labels like confidential, personally identifiable information, or financial. This is particularly important for organizations subject to GDPR, the General Data Protection Regulation, which requires you to know exactly where personal data lives in your systems. As of this writing, data discovery and classification is in preview, but available at no extra cost. The second layer is vulnerability assessment. This performs an automated security scan of your database configuration and reports on potential weaknesses. For example, it might flag that your firewall rules are too permissive, that sensitive columns have not been classified, that certain permissions are misconfigured, or that specific security best practices have not been followed. It produces a detailed report with specific remediation guidance for each finding, and it tracks changes over time so you can see whether your security posture is improving. The third layer is threat detection, and this is the most powerful one. It applies machine learning to your database's login and query history to establish what normal behavior looks like. Then it continuously monitors for deviations from that normal behavior and sends alerts when something suspicious occurs. For example, if one of your SQL logins always connects from the same Office IP address and suddenly tries to log in from an IP address in a different country, threat detection will flag that as suspicious. If a login that only queries the database during business hours suddenly attempts access at 3 in the morning, you will receive an alert. And if the system detects patterns that look like a SQL injection attack, where application inputs are being used to modify query logic, you will be alerted immediately. All three layers can be enabled at the individual database level or at the SQL server level, which applies the protection to all databases on that server. Let us cover auditing and dynamic data masking together, since they address related but distinct security concerns. Auditing is about accountability, tracking who did what to the database and when. When you enable auditing, Azure logs every significant database event, logins and failed logins, queries executed, permission changes, schema modifications, and administrative actions. These logs are written to an Azure Storage account, a log analytics workspace, or an event hub, depending on how you configure it. You can define how long to retain the logs, the retention period, and you can enable auditing at either the database level or the server level. Server-level auditing applies to all current and future databases on that server, which is typically the more efficient choice in production environments. Auditing is not just a nice-to-have feature. For many organizations, it is a hard compliance requirement. Standards like SOC 2, ISO 27001, PCI DSS, and HIPAA all require organizations to maintain logs of access to sensitive systems and data. Azure Auditing fulfills this requirement automatically once enabled. Dynamic data masking is a completely different concept. Rather than logging what people do, it controls what they see. The goal is to allow different users to query the same table but receive different results based on masking rules. Here is a concrete example. Imagine you have a customers table with columns for name, email, phone number, and credit card number. A customer service representative needs to access this table to help customers, but they have no legitimate reason to see the credit card numbers. That should be visible only to finance team members with appropriate access. With dynamic data masking, you create masking rules that apply to specific columns. When a user who is subject to masking runs a select query, the masked columns return obfuscated values. For example, phone numbers show as a series of X characters, and email addresses show as just @masked. But users who are excluded from the masking rules, such as the SQL administrator or designated privileged users, see the real, unmasked data as normal. To configure a masking rule, you navigate to the Dynamic Data Masking blade, select the schema, table, and column you want to mask, and choose a masking format. The formats include options like default masking, email masking that shows only the first letter and domain structure, random number masking for numeric fields, and custom string masking where you define the exact pattern. The same table, queried by different users, returns different results, without needing separate tables, views, or complex application-level filtering logic. Transparent data encryption, commonly known as TD, addresses a different threat: physical data theft. What happens if someone obtains the raw database files from disk? What if a backup file is accidentally exposed? Without encryption at rest, the data would be readable directly from those files. TD solves this by encrypting the database files, backup files, and transaction log files at rest, meaning while they are stored on disk, so that even if someone gets the physical files, they cannot read the data without the encryption key. Here is what makes TD genuinely elegant. It operates completely transparently to the application. There is no change to your connection strings. There is no change to your queries. There is no performance overhead that you would notice at the application level. The encryption and decryption happen at the storage layer, below the SQL Server engine, so neither your application nor your database code needs to be aware of it. How does TD work technically? Each database has a database encryption key, which is a symmetric key used to encrypt the actual data files. That key is itself protected by a certificate or an asymmetric key stored in the master database. When Azure Key Vault integration is configured, the protecting key can be stored and managed in Azure Key Vault for enhanced security and key rotation capabilities. Now, here is the striking difference between TD on Azure and TD on-premises. On SQL Server in a traditional data center, setting up TD requires manually creating and backing up certificates, configuring key management procedures, and ensuring you do not accidentally lose the encryption keys, which would make the database permanently unreadable. It is a careful, multi-step process. On Azure SQL Database, TD is enabled automatically for all newly created databases. It is simply on by default. For older databases that were created before this became the default, you can enable it by toggling a single switch in the Azure portal. Nothing more complicated than that. And because Azure manages the key infrastructure, you do not need to worry about manually backing up certificates. All backup files created by Azure SQL automatically inherit the encryption of the source database, so your backups are always protected. A database that is secure and highly available still needs to be monitored and tuned for performance. Azure SQL Database provides a rich set of monitoring and troubleshooting tools that go well beyond what traditional on-premises SQL Server tools offer. Let us look at the four main tools. The first is Performance Overview. This is your dashboard for understanding how your database's queries are consuming resources. It shows you aggregated resource consumption broken down by database transaction units, CPU, and input-output operations. The key insight here is which queries are consuming the most resources in total, which might be because a query is inefficient, or it might simply be because a query runs very frequently. There's also a long-running queries tab, which identifies queries sorted by the time they take to execute. Between high-frequency queries and long-running queries, you can pinpoint where optimization effort will have the biggest impact. The second tool is Performance Recommendations. Azure analyzes your database's historical query execution patterns and generates specific, actionable recommendations for improving performance. These might include creating a new index, dropping an unused index, or addressing a specific schema design. Recommendations are ranked by the estimated benefit. You can review them and apply them manually, or you can configure Azure to apply them automatically. The third tool is Query Performance Insight, which is similar to Performance Overview, but with more customization options. You can configure the time period you want to analyze, the metric you want to graph, CPU consumption, duration, execution count, and so on, and drill down into specific queries. This is especially useful for observing performance trends over longer periods, such as identifying whether a particular change you made last week improved or degraded performance. The fourth tool is Automatic Tuning, which we will cover in more detail on the next slide. But at a high level, it applies machine learning to automatically apply performance improvements on your behalf, without requiring a database administrator to manually analyze and implement changes. Automatic tuning is one of the most impressive features of Azure SQL Database, and database administrators who have spent years manually analyzing and tuning query performance tend to appreciate it enormously. At its core, automatic tuning uses built-in intelligence combined with machine learning to continuously monitor query performance, identify problems, apply fixes, measure whether the fixes actually helped, and undo them if they did not. This is a feedback loop that operates continuously 24 hours a day. There are 3 specific tuning actions that automatic tuning can perform. The first is force plan. SQL Server's Query Optimizer generates an execution plan for every query, a step-by-step strategy for retrieving the data. These plans are cached and reused. But sometimes the optimizer generates a new plan that is actually slower than the one it replaced, a phenomenon called plan regression. Force plan detects when this happens, automatically forces SQL Server back to the last known good plan for that query, and prevents the performance regression from persisting. This alone can prevent significant, unexpected performance degradation. The second action is create index. Automatic tuning analyzes query patterns and identifies columns that are frequently used in join conditions, filter conditions, or order by clauses. If creating an index on those columns would speed up queries, it creates the index automatically. Importantly, it then monitors whether the new index actually improved performance. If the index provides no measurable benefit, or if it is never used, automatic tuning will remove it. The third action is drop index. Over time, databases accumulate indexes that were created for queries that are no longer run, or that were redundant with other indexes. These unused indexes waste storage space and slow down every write operation because the index must be updated whenever data changes. Automatic tuning monitors index usage over time and drops indexes that have not been used in a significant period. You can configure automatic tuning at 3 levels. The server level, which applies defaults to all databases on the server. The subscription level, or on a per-database basis where individual settings override the server defaults. For each of the 3 actions, you can independently enable or disable automatic execution. One of the most reassuring aspects of Azure SQL Database is that backups are completely automatic, require no configuration to get started, and are provided at no additional cost as part of every database tier. When you create an Azure SQL database, Azure simultaneously creates geo-redundant storage and begins running a continuous backup chain. Let's look at the 3 types of backups and how they work together. The first is the full backup. Azure performs a complete backup of the entire database once per week. This is the baseline from which all restores begin. The second is the differential backup. A differential backup captures all changes made since the last full backup. Azure runs differential backups every 5 to 10 minutes, depending on the size of the database and the volume of activity. These frequent differentials mean that after restoring a full backup, you only need to apply a relatively short chain of changes to get close to your desired restore point. The third is the transaction log backup. Azure captures transaction log backups every 12 hours. The transaction log records every committed transaction in the database. And by replaying these logs on top of a differential restore, you can achieve very precise recovery. Together, these 3 types of backup enable what is called point-in-time restore. If something goes wrong, accidental data deletion, a bad update, or corruption, you can restore the database to any specific minute within your retention window. The process is, first, restore the most recent full backup before your target point. Then apply all differential backups between the full backup and the target. And finally, replay all transaction log backups up to the exact minute you want. This gives you extremely fine-grained recovery capability. The standard retention period for backups ranges from 7 to 35 days, depending on the service tier. All standard backup storage is included in the price of the database. For organizations with longer retention requirements, auditors, regulatory compliance, legal hold, Azure also offers long-term retention backup, or LTRB. This allows you to keep database backups for up to 10 years. LTRB uses additional Azure storage, which is charged separately, But given the low cost of Azure Storage, the additional expense is modest. If your organization is required to retain financial records for 7 years or patient records for 10 years, LTRB makes this feasible and manageable. There's also a database export option. This allows you to export a copy of your database as a backpack file, which is a single file that contains both the schema, all your tables, views, store procedures, and other objects, and the data itself. A backpack file can be stored in Azure Storage or downloaded, and it can be used to restore the database to a completely different Azure subscription or SQL Server instance. This is useful for creating development copies of production databases. Everything we have covered so far has centered on SQL Server and Azure SQL Database. But it is important to step back and recognize that SQL Server is just one part of a much larger Azure data platform. Azure supports virtually any database technology you want to run in both the infrastructure as a service and platform as a service models. For relational databases in the infrastructure as a service model, the options are effectively unlimited. You create a virtual machine with any supported operating system, and you install whatever database software you need. Oracle Database, MySQL, PostgreSQL, IBM DB2, any of these can run on Azure virtual machines. And the Azure Marketplace offers pre-configured images with many of these databases already installed, so you do not have to start from scratch. For NoSQL databases in the IaaS model, the same flexibility applies. MongoDB, CouchDB, Cassandra, Couchbase, all available either through manual installation or through marketplace images. Moving to the platform as a service model for relational databases, Azure offers several fully managed options beyond Azure SQL. Azure Database for MySQL is a fully managed MySQL service. Azure Database for PostgreSQL is a fully managed PostgreSQL service. And Azure Synapse Analytics is a massively parallel data warehousing service designed for analytics workloads at scale, terabytes to petabytes of data. For NoSQL in the PaaS model, Azure Cosmos DB is the flagship offering. It is a globally distributed, multi-model database service that supports multiple APIs, including SQL-like queries, MongoDB, Cassandra, Gremlin for graph data, and Azure Table Storage. Cosmos DB guarantees single-digit millisecond latency at any scale, anywhere in the world. The analytics ecosystem extends further still with Azure Data Factory for data orchestration and ETL workloads, Azure Databricks for Apache Spark-based data engineering and machine learning, and Azure HD Insight for managed open-source analytics frameworks like Hadoop and Hive. The key message is this. Whether you are migrating an existing Oracle database, building a new cloud-native application on Cosmos DB, or running petabyte-scale analytics on Synapse, Azure has a data service that fits. You choose the right model. IaaS for maximum control, PaaS for minimum maintenance, and Azure provides the infrastructure. Let's close with the 7 key takeaways from this chapter. Takeaway number 1. Azure Storage is the foundation. Blob, file, queue, and table storage together underpin virtually every Azure service. Understanding which storage type to use for which scenario is fundamental knowledge for any Azure professional. Takeaway number 2. Azure Backup and Azure Site Recovery serve complementary but distinct purposes. Azure Backup is about data protection, recovering individual files, databases, or machines from point-in-time backups. Azure Site Recovery is about business continuity, keeping entire workloads running during disasters by failing over to Azure. You often need both. Takeaway number 3. Geo-replication and failover groups are not the same thing, and the difference matters. Geo-replication creates a readable secondary copy of your database in another region, but failover is manual. Failover groups wrap a geo-replicated pair with an intelligent endpoint and automated failover logic, giving you true high availability without manual intervention. Takeaway number 4. Azure SQL security is multi-layered, and each layer addresses a different threat. Threat detection protects against behavioral anomalies and attacks. Auditing provides the accountability and compliance trail. Dynamic data masking protects sensitive data from being seen by unauthorized users. And transparent data encryption protects the physical files at rest. You should consider enabling all four for production databases. Takeaway number 5. Monitoring with automatic tuning can replace or significantly reduce manual DBA work. Performance overview, query performance insight, and performance recommendations give you visibility. Automatic tuning, force plan, create index, drop index, applies improvements without human intervention using a machine learning feedback loop that is always running. Takeaway number 6. SQL database backup is automatic, free, and highly capable. Full, differential, and transaction log backups run continuously without any setup. Point-in-time restore lets you recover to any minute within your retention window. And long-term retention backup extends that window to 10 years for compliance scenarios. Takeaway number 7. The Azure Data Platform is vast. SQL Server and Azure SQL Database are just the entry points. MySQL, PostgreSQL, Cosmos DB, Synapse Analytics, Data Factory, Databricks. Azure offers a complete ecosystem of IaaS and PaaS data services covering relational, NoSQL, analytical, and real-time workloads. Match the right service to the right workload, and you will get the best combination of performance, cost, and manageability. That concludes our chapter on Azure Storage, Backup, and Site Recovery. In the next chapter, we will explore your options for migrating existing on-premises applications and databases to Azure, the practical tool set for accelerating your cloud journey. Thank you for watching.